Okay, so we are live. Hello, everyone, and welcome to Kubesimplify and Cloud Native Sustainability Week. My name is Sayam Pathak, and I'm a CNCF ambassador working as field CTO at Sivo. And today I'm joined by Divya.
Hi everyone. My net is a bit glitchy, so I am going to apologize in advance if there is a sort of um, break in between what I speak. So I'm Divya Mohan, and thanks Ayam for introducing me. I am working with SUSA as a senior technical evangelist, and I'm also a CNCF ambassador, and I also am a maintainer for docs on Kubernetes. So,
Awesome.
Sayam, do you want to lead us on into what's cooking for today?
Definitely. Like I have been, so I and Divya have been planning this for quite some time now, and we have been trying to read what is happening in the cloud native sustainability era, or you can say the domain, specifically of post KubeCon EU, when we saw a lot of keynotes, a lot of talks that highlighted the sustainable software computing, some of the toolings which are there, which are existing in the cloud native ecosystem, and that you can use as of today to create your significant impact for the reduction of carbon footprint or knowing about those stuff. A lot of these things will be discussed throughout the week. So this is where the CNCF, and there is a thing called tag. So if you are aware, CNCF has something called tags, and there is a tag environment sustainability under CNCF, and that is where they have created this second week of October, which starts today, leading up to the end of the week, focused mainly on Cloud Native Sustainability Week, where events are happening all across the globe, virtually, in person, different meetups, different time zones, in person, virtual, and as part of that, Kubesimplify is also doing a series of streams with different industry leaders and experts to hear about various open source projects, their journeys, what they are doing in this space, what or their organization are doing in this space, and how we can learn and then implement some of the solutions out there to create an impact and be part of it. Uh, Divya, you want to add anything more on CNCF or tag environment sustainability?
Absolutely. I think you covered it all, to be very honest. But I genuinely think that with this, what Sayam and I hope to do is not only spread awareness, because obviously that is one of our end goals. Like if we need to understand something, we need to have more awareness around the topic. But it's also to start a discussion around this topic, because as we all know, climate change is a very real thing, right? And environment sustainability and in general sustainability of the tech that we use is an extremely important topic that needs to be discussed. So these discussions need to happen, and we aim to get the ball rolling with this set of live streams. So the discussion, the learning, the awareness generation doesn't just stop here. We highly recommend you to jump in on the CNCF Slack, and join the Tag Environment Sustainability channel, because they're doing some fantastic stuff in this regard. And we and with this we really hope that you actually have an or are able to get interested in this topic and are able to contribute your bit towards helping our tech be more sustainable. Yeah, that's pretty much it.
Awesome. Cool. So we'll get started because there's a lot that is to be covered today, and we will be going through some of the very interesting topics. And for that, I would like to introduce and call Henrik on the stage. So Henrik, hello and welcome to this Cloud Native series day one. Always the most build up pressure that is there for day one. That has to be that has to be hyped up and the best one. So So welcome on day one. Henrik is from Dynatrace, and we recently just met at CO Navigate as well, and had a good conversation. Same with respect to the sustainability efforts, and he was also there on one of the sustainability talks. And there I got to know that he already is doing a lot in this particular space. Dynatrace is already doing a lot in this particular space. So I thought, like, why not learn some of the tools from Henrik and see how we can use that today. So Henrik, stage is all yours, and we'll definitely pop in here and there to ask you questions from the community and from ourselves. But yeah, let's go with what you have.
All right, so cool. Thanks for first of all, thanks everyone to be connected here. Again, if you have any questions or anything that you want to have more details on, just ask, and I would love to pose because I can talk a lot, but it's more to interact with all of you. So what I want to here to cover to today is to present you the first of all, maybe before we start, a brief introduction. So my name is Henrik. Rex said I am a cloud native advocate. I am passionate about observability in general and performance. So that's why I have a YouTube channel on the topic. And that's how I discovered a few months back. I was looking for eBPF technology and Prometheus exporters, and I came across Kepler, and I was very excited about the product itself. So today, I would like to introduce you several tools. So I want to cover what we have done at Dynatrace to cover that aspect. Of course, I want to present the open source solutions that are out there. So Kepler, as you can see here, is the GitHub repo to Kepler. So if you want to deploy it or try it out in your environment, here is the URL. There's the documentation is fairly easy to so you don't no major effort to get into the solution itself. And the second one is Cube Green, and you'll see that Kepler is or Dynatrace are great, but Kepler provides our tools or solutions on how we could basically reduce the energy consumptions. So before we jump into showing you the product and the various stuff, I wanted to explain a few things. So today, as an organization, we consume a lot of energy. If you want to reduce the carbon footprint, there is a lot of areas we can do. So by putting some reducing the travel policy, so we can reduce less carbon usage through travel. But in the IT environment, of course, what we want to do is to focus on our code and our solutions and how we can reduce the energy related to our solutions, the code that we're building. So to do that, there are a few areas where we can optimize. The first one I would say is to be able to optimize, you need some measurements. So have a tool that you can use in your environments that will measure the energy consumptions of your workload. So then you can take actions. So once you have that, then you can start to making an optimization process. So I can reduce the cost by looking at my code, so optimizing my code aspect, and I can basically use the energy as a KPI, main KPI. We can even think about regressions on the energy usage of our code, and we can implement that into our processes. So I think that's one aspect. The second aspect is well known in the Kubernetes world. I would say that when we have the ability to define our resources, there are some downsides where people have try to over allocated resources, and at the end we are not very optimizing the usage of our node, and at the end we are adding more nodes, and at the end we're consuming more energy. So I think optimizing the workload size by touching the requests and limits of your deployments or stateful sets, I think would be a good start to reduce also the optimize a bit more the way you're utilizing the resources within your nodes. And last is it's good to know to do some optimizations, but in dev environment, in staging environment, we have applications running. So when we are actually in the office or during the working hours, those workload are there running. But once we get back to home, there are obviously down at night hours, I would say, where nobody is here, nobody's doing anything on the environment, so there's no traffic. So then we are having workload that just consuming energy for nothing, and this is obviously not good at all. So I think let's cover how we can reduce that, but we're covering the various solutions. So to start, I will cover the aspect of collecting data, because if you want to optimize, like I said, you need KPI, and the best way to do that is to utilize solution of the market. So first solution, of course, because we work at Dynatrace, when we implemented the new platform that we have since 9 months ago, we delivered an app because we have the ability to build applications within with our platform. And one of the app that we delivered on the first one was the carbon footprint application. So I'll showcase that application in a few minutes. The idea of the carbon footprint is obviously to, first of all, provide to our customers and users how much energy they are consuming and what is the carbon footprint usage of the actual environments that they are running into their data centers. So especially now with the European regulations, now you have to basically report the carbon footprint usage, and having an options, a tool that gives you that information is still relevant, of course, because at the end, we don't have to guess for those numbers. The second thing is having the numbers is great, but then we try to figure out if there is some workload or host, I would say, that could be optimized. So here I'm really fishing the approach of I have allocated 1 gigs of memory, but I'm only using 200 megs. So at the end, I have over provisioning some nodes. So I could basically downsize the resources, and then I will have a better usage of my nodes and my infrastructure, and I can do more with the same servers instead of provisioning extra effort. So that's the approach of that applications. We were probably gonna improve it in the future, but that's the first feature that we provided. So to start, at least we have the measurements, and also we give you insights on what should be at least optimized in terms of configurations. The second aspect is an application that I showed you a few minutes ago, Kepler. So it's in the Systemability GitHub repo. You have Kepler that is available there. Kepler is, I think, a really exciting project. A lot of engineers has worked on the solutions, and it's basically it's utilizing a technology eBPF. So a lot of people are talking about it. The concept is very simple. You deploy some probes in your servers, and to measure the CPU consumptions, they will do that through the number of CPU cycles. So they are able to measure the CPU cycles used by various workload, and then provide the energy consumptions that are related to your applications, to your deployments, to your namespaces. So then they give you all the different dimensions. So then you can basically keep track on who is spending what, and then take actions from there. So here Kepler is mainly a solution exposing what you're consuming, but it won't give you any insight on any tips on what you should basically optimize. That's why we need the other solution, which is KubeGreen. KubeGreen you won't use it heavily in production, I guess. But I guess for all the other environments, so dev or staging, now we have a tool in our hands where we know that we're consuming energy. We know that we have applications that are that requires a significant amount of CPU, but during the night hours, I don't need that. So let's turn off those applications. So then we can reduce the energy required to those applications. So how does it work? So KubeGreen at the end is a Kubernetes operator. It introduces a new CRD, the sleep info, and then you have to configure manually what do you want to make to make sleep to sleep. In fact, so you deploy it on given namespaces, and all the workload that are in that namespace will sleep. And then of course you have a lot of different configuration. You can make some exceptions. I don't want to make the couple of all the workload that having those labels. I don't want to be touched by this. I can also make some exceptions about I don't want to make the cron job sleeping. So you have a lot of different approach of configuring. But still, as of now, you have the CRD, but you are the one that needs to know, okay, so we know that 5 p.m. people are leaving the office, and then there's nothing until the rest of the day. So I think this is a great way, but I would love to have automation, and I tried to. When Sen reached out to me, I said, "Oh, let's do a demo, and let's try to find a way where we can automate the configurations of KubeGreen." So I prepared a technical environment. I don't have it pushed to yet on GitHub, but I can share the link after this live stream. So in this demo environment, what I did, I defined 2 workloads, so hotel demo and the hipster shop. I have KubeGreen, of course, the operator. I have Dynatrace because I want to showcase the carbon footprint app, and I have Kepler. And of course, my workload utilizes Istio, so I have also Istio on the side. On the default namespace, as you can see here, there's an amplifier with a collector. I usually put that as an icon to the Open Telemetry collector. So I'm using the Open Telemetry collector to basically collect data from using Open Telemetry or Prometheus receivers. And then with that component, I'm able to push the data back to Dynatrace in my case, but you can also send it to other destinations. So which means I won't use the Grafana dashboards of Kepler today. I'm going to use Dynatrace. So all the data will be ingested in Dynatrace. And then I will build a dashboard using the Dynatrace UI. So then we will always stay into Dynatrace. The story of here is very simple. I have deployed a cron job, so a load test, on the hipster shop only. The hotel demo, there's some fake traffic, and this traffic running during 24 hours. So this app is not supposed to have sleeping hours. And then we have the hipster shop. In the hipster shop, I have created a cron job where we have a load test that runs an hour, and then I modify the hours of that load test. So then I need to figure out the right settings for KubeGreen. So then the hipster shop will be sleeping out of the load testing hours. And so then I can take actions and reduce the energy usage for sure. So let me show you this into the screen itself. So fresh, let's start with the carbon footprint application that I mentioned before. So in the left side, you can see we have carbon footprint here. Okay, let me refresh because for some reason that's the, okay, here it is becoming. Okay, so the carbon footprint app here is, so it shows me the usage over the last 3 days. I can see the actual consumptions of CO2, and in here you can see that there's a change. Why? Because since Friday, I have implemented the KubeGreen settings, so I was able to reduce significant amount of CO2 with the help of KubeGreen. But here I have disabled it because I wanted to showcase how we can configure KubeGreen in a smart way. So what this provides, it provides first of all the default dashboards, but then I can jump into a data center. So here I have a Kubernetes cluster running in the cloud, and you will see that it will show me the various hosts. So hosts, in fact, will be workload in my case, and then I will be able to see what its usage, and then it provides some optimization saying, here I'm consuming this amount, and the few information to figure out if we can optimize. So in my case, there is no major optimization because I didn't want to showcase this app, but I will just wanted to remind you that there is already something in Dynatrace, but it will be quite similar to what Kepler provides in a sense. So what I did here, let me jump to Kepler, where I have created a specific dashboard for Kepler in Dynatrace. And so here I'm Kepler at the end is a Prometheus exporter. So if you're able to collect the various metrics produced by Kepler, then you can utilize those data in Grafana or other solutions. So what I did, nothing specific. I just asked, in my case, the Open Telemetry collector, but I can also use the Dynatrace functions to do that, to collect the data from this Prometheus exporter. And then once I have the data, I can visualize the data, plot, create graphs. So what I tried to do is basically take the actual Grafana dashboards available in the Kepler applications and recreate the similar visualizations, similar, I would say, So I'm able to see the CO2 call per namespaces, so show which one is consuming the most. Same thing for the CO2 petroleum and CO2 coal as well. Last, I on the namespace level, my intention was to show which namespaces are consumed the most. So you can see that default namespace is quite significant. So it helps me to figure out what is actually consuming energy within my cluster, and then take actions from there. So it's similar to the app that I showed you before, but what I really liked is, for example, if I pick, let's say, Open Telemetry Demo, where I have actual workload, and I'm pick, let's say, one of the workload running here. Here it is. I have, at least on a specific pod usage, I can see which components is consuming the most. So in this case of this feature flag container provided in the hotel demo applications, you can see that actually it's the feature flag service, the Polar, that is the most expensive. We can see that we have Istio proxy, but it's taking very low, a minor footprint. So at least even within the pod, with this, by showing you the processes, you can figure out in the pod which container is consuming the most. And then from there, say, okay, if I use a service mesh and we realize the service mesh is the most expensive one, it should not happen, by the way. But at least you can take actions and remove or ask the team that in charge of that container to optimize it. So now that we have this, what we want to do, if I show you the last few things, I have reconfigured this afternoon the workload, and let's jump into the Hipster Shop namespace. Here it is. Where is it? Hipster Shop. And what I want to show you is the actual usage. So here, if we go to the last 6 hours, we can see that we have in this particular story here is that I have my Hipster Shop application deployed. So it's consuming already some CPU. It's consuming, at least it's been allocated. So we have allocated those resources, and we can see that actually during just this time frame, if I zoom in here, I can see that during that time frame, there is only load during a specific moment of the day. So, which give me a sign that I am allocated resources and I'm consuming energy for nothing. So it would be great to have the options to turn off that specific workload to reduce the energy. So this is where kubegreen comes into picture. And so there is 2 options of doing this. The first one is simply doing it by configuring your workload, defining your hours. But like I said, you would have to know when you have to make the workload sleep and when it has to wake up. And by the way, what does that mean? Make your workload sleep. Kubegreen will take your deployments in that namespace and adjust the number of replica to 0. So at the end, there is no pod, no container running. And then once we arrive at the wake up time, it reconfigure your deployments with the right numbers, so everything runs as expected. So if I want to automate the flow, what I've decided is say, I have Istio, or I took Istio as an example. I have Istio, which means with Istio, you have an envoy, a proxy. And with that envoy, you know exactly through the access log, because all those technology generates logs. I can know exactly when we have the first request of the day and when we receive the last request of the day. So here I'm using Dynatrace query here. What I'm saying, I'm going to fetch the logs, and I am parsing the logs related to the envoy logs. I'm filtering out the OpenTelemetry request, because at the end, I'm not interested on those. I'm mainly focused on the application level. And then what I want to do is if I run that query, I want to figure out when is the first request of the day and when is the last request of the day for each given namespaces. So here in this particular example, and I also, what I'm trying to do is to figure out a time frame that is under 3 hours and less and above 1 second, of course. And the idea is that if I have a time frame of 3 hours where we're doing nothing, why don't we sleep this workload? So that's the query based on observability data. So I took the envoy, but you can be creative. If you have other solutions in your cluster that provides that information, at the end, again, what you want is to identify a time frame where where your application are not used, and then from there, try to identify the sleeping time and the wake up time. So here I have the actual daytime, the first request and the last request. And then what I want to do is to put some security. So I'll put 30 minutes before that time, we will sleep. And on the opposite, the last, at 30 minutes later, so at 1:30 a.m., we will basically no, so the opposite. So it's last, I'm sleeping at 1 a.m. and I'm waking up at 11 p.m. So that's how you were going to configure it. So how do you do that? You can do it in various way. What I did a workflow in this particular case in Dynatrace. So workflow is a way of automating processes in using different events and so on. And in my case, I'm running it every morning at 9 a.m. Of course, you can be creative and say maybe if we have an increase of usage of carbon or energy usage using the Kepler data, we can take that as an input event. But in my case, I'm scheduling it every day. And what I do, I run that query. So in my case, I change it to 8. In this demo, I did it at 8 hours, but we can change to, because see now, if I run that workflow, I won't have any major configuration. So let's modify it to 3 hours. So that's the query I just showed you before. And then I have a small script that will take advantage of the data, and that will reconstruct the actual YAML file. And then at the end, I took a Slack message, but again, we can be even more creative in this particular case. Instead of a Slack message, we can reach out to Git, make a PR in our GitHub repo with a sleep info object. And then if you have a GitOps process, it will be deployed automatically. So there is various way of doing it, or you can open a Jira ticket and someone takes it in the morning and deploy that particular sleep info CRD. So let me save and run. So now what it means, it will send a Slack message. So let me open the Slack workload. All right, it's running. So in a few seconds, we should see a Slack message coming in. All right, still running. At least this is what I received this morning at 9 a.m. Saying that I should, in the default namespace, because I had some bugs with my open telemetry collector, this is the time where I should shut down the open telemetry collector. And here was for the hotel demo. So saying at 3:30 and 6, you can basically shut down the hotel demo, but I had problems on my application itself. So that's why I had that. So at the end here, it's 5:57. Oh, so it's the message of today. So we just received it. So here it's saying, for example, for the hipster shop, if we want to configure the hipster shop to sleep, we will have to turn off the hipster shop at 11:46 and wake it up the next day at 9 p.m., 9:26. So at the end, Green is great. But again, if you have some workload changing in your environment, it could be quite time consuming to identify the right timing. And I think relying on observability data, you would have the options to do that. To do so in an automated fashion, like explained, with the various assets that I shared you today. So one last thing before you have any questions or anything, I wanted to explain how you get the data, because at the end, we rely on data. And if you want to automate that process, if you don't have the data in your environment, then you won't be able to automate the process. So for this, I would definitely recommend to add an open telemetry collector. So this is what I did. So OpenTelemetry collector CRD is provided with the OpenTelemetry operator. And as a consequence with this, as in this particular case, I'm reading the logs from the various pods running in this cluster. And last thing I did to get the data is using the Prometheus receiver. And this Prometheus receiver, you can see that it's getting the Kepler metrics every 5 seconds. And also I'm dropping information that I don't need for my particular use case. And again, if you want to collect everything, you can do that. But sometimes if you want to optimize also the data that you're sending to your observability backend, it makes sense to reduce the amount of data going through the environment. So at the end, if you want to reduce the energy of your environments, like I said, first measure. So Kepler or Dynatrace or any other solutions that are providing those numbers. Again, it's very important that you have the right granularity because if you have the energy on the overall node, it's going to be a good information, but you want to have the right information to figure out who is consuming what. So being able to split it by namespaces, by pod, by anything that is in your environment will be very crucial to start taking actions into your environment. Second thing I showed you is KubeGreen. So KubeGreen is obviously very important because at the end now you have a solution, you have a tool that is powerful that allow you to reduce an unuseful workload or unused workload, I would say, by defining this sleep time and wake up time. So combining both will allow you to reduce the energy consumptions and then again reduce the carbon usage on your environments. Of course, with the KubeGreen solution, we could even imagine other processes. And I think we could basically, if everyone is interested in the project, it would be great to imagine having also like a sort of a broker similar to Knative, for example. So if we are shutting down the environment, so there's no app running, if someone run a test, then the user will say, what is happening? Is it a bug or is it not a bug? So having maybe a broker that takes the message and display an answer to say this environment is currently sleeping would be beneficial. So I think we can basically upgrade the project by providing a few other components. So then if anyone jumping in the cluster and doing any traffic, at least be aware that this environment is currently sleeping to save energy will be useful and avoid misinterpretations, I would say. Do you have any questions or any?
Cool. Yeah, definitely. So there are a couple of questions in the chat. First, I can read through that maybe, and then we can continue the discussion from there on. Okay. So we'll take the latest one first. So Andreas is asking, what would happen if a request comes in while the KubeGreen paused the pods?
That's a great question. So that's what I'm trying to suggest as an improvement of KubeGreen. It would be great to have like a sort of a broker or a proxy or something that takes the request and store it. Similar to Knative, when you have a serverless technology, you have a sort of broker that takes the request and then spin up the right service. So having a similar component that will take the traffic and at least if there is no app running, responding back to the application, to the app saying, hey, it's currently off, at least be aware of something is off, or even maybe re-spin up the environment or changing the replica sets would be useful. As of now, we just sleep at certain time hours, but there is no other actions if there is some incoming traffic. So I think the project could be improved. Again, feedback like this is very useful because I think we can improve and make KubeGreen even more powerful for sure.
Yeah, I think scaling down to zero is definitely worth it for the dev stage. These kinds of environment where you don't have any, like you said, you don't have any production traffic coming in, and you can scale down your pods in the non-working hours or the non-active hours, so when the developers are sleeping. So that makes sense to just sleep them away. But yeah, these type of scenarios where if you want to run kubegreen in production, then definitely this particular or these type of scenarios has to be taken into account, where definitely the request, I know there are time durations where you get max traffic, peak traffic, but there is no definite guarantee that you won't get it, because there might be a single request or two requests that could fail. But we don't want to fail that, so we should try to have something in place, like you said, a broker or something in place that can at least scale to one replica if the workload comes in, and then overtakes the sleep of that, serves that request, wait for a certain amount of time, and then sleep back again. So um, yeah, that can be very good, interesting stuff that can be added to kubegreen and making it actually be able to run in production.
Yeah, I agree. I think as of now, kubegreen, from my perspective, is great for non-production environment, but I would definitely not use kubegreen in production environment. I mean, the having a downtime in production because we try to save energy is great, but I'm pretty sure that the CEO or the business won't be very happy, and I guess we have a lot of negative impact out of that for sure.
Yeah. Another one is so Kepler help in compare power consumption for the same app on different CPU architects. Like, can it do on different CPU architectures? Would it work on cloud providers where there is nested virtualization?
I think again, this is like I said, it's taking it's using eBPF probes. So here I'm using it in a cloud environment. To be honest, this deployment, so it works perfectly well. It's on a virtualized CPU. Um, on the CPU type, I'm not sure. I will have to check on the documentation. I'm pretty sure that it should work, but I'm not 100% sure on that answer. But yeah, clearly, keep in mind that again, there is nothing exposing the real power conception. So the Kepler project decided to let's make an algorithm based on the usage on CPU cycle and memory allocations. So every time there is something through the eBPF technology, you can basically get the events from the kernel. That's the main concept of eBPF technology. So you attach a program that will be running at specific kernel events, and they picked basically a CPU cycle usage or memory allocations, and they are able to get who is consuming what and providing again. And they suggested an algorithm to say let's measure the energy usage based on the cycles. So it's an estimation. It's not 100% true, but at least with those KPI we can take action. Again, this Kepler solution doesn't know if, for example, I'm using let's say a carbon a green environment that doesn't consume carbon footprint. He's not aware, so I'll still have some CO2 estimated. But again, this is you are the one knowing where you're deploying your workload, so you will have to figure out if you need that KPI or not. But again, it's having a KPI is still useful and helps you to improve for sure.
Yeah, just to add to that point that Henrik was just mentioning, that there is no one-to-one mapping. It's the reference calculations that takes place. So for example, the CPU instructions, which is the capacitance and the frequency. So capacitance is usually the number of circuits that are running, but we cannot measure that. So to measure the capacitance, it is measured in terms of, like, for the CPUs, it's measured as CPU instructions. And same for the frequency, we cannot measure the circuit frequency, but we can measure it from the CPU counter. So like this, there are different one-to-one mappings, or the different set of mappings that has been done. And then these metrics, like you can see on the screen itself, they are getting to the machine learning model which is there, and getting enriched the data to get the carbon footprint. So gathering the metrics and then enriching the data against the model that you're running locally or online, and then getting the another set of metrics that gives you the actual power consumption per node, per namespace, like Henrik just showed in the demo end to end. And then you have it as Prometheus format. So you add the data source in Dynatrace, Grafana, or wherever you want to have that fancy dashboards. so you will be able to see that. Cool. So one thing I really liked is the automation stuff, Hendrik, which is uh, defining yourself about the cube green consumptions and finding those hours where the peak time is not there. I think getting that as well from the metrics, and based on that metrics generating the YAMLs and applying them really, I think it's the ideal automated way, in the cloud native way, that we move towards more and more automation to get more and more stuff automated. I think that's really cool. um, yeah, I think that's really powerful. I think that can also be suggested as maybe Kepler, some webhooks that people can use, different set of workflows. I don't know if we can try to do similar in the Argo workflows, try to replicate the same behavior. I'm not sure,
I think
but
I think the you rely on observed data, so you need something that query the data and give you numbers
yeah,
and give you not only numbers. So I started with the metrics. The problem with metrics is that you can have a results on the average, but you will never give you the right date. We're looking fishing for dates, so it's more complicated to get from the from the metric perspective. So I thought that the two major signals that will give us insights would be logs in one hand, because we already always have logs, and the other one was spans. So I thought that, oh, if we have a trace and then we don't have anything, we have a lot of trace during that time frame, and then we have nothing. So getting the last span and the first span of the front end layer would be a way of capturing those dates. I think logs, again, I took the envoy, but if you're using, I don't know, nginx or using any other solution, you could do the similar approach. Dynatrace has a query language on the logs, but if you are a user of Grafana, Loki, you can do this. I guess you could do the same thing with Loki. I guess so. But again, what you're fishing is to get the first entry in the log in your access logs, the last entry of the log, and then calculate the duration. And from there, you can see, okay, what is uh, if a workload is not is there is nothing during 3, 5, 8 hours, then let's shut it down. But I think that's Observity is the right way of detecting if there is actual traffic. Kepler will give you the energy. What would be interesting is to basically then query Kepler the day before and the day after to see if we have improved, and see if we have, let's say, some ratio of efficiency, I would say, on the settings. That would be interesting. But Kepler won't give you this start and end date. It will basically give you what you're actually consuming at the moment.
yep, I
Um,
think so.
yeah, I'm sorry. Just go ahead. I'll ask my question later. Not a problem.
Yeah, so just to conclude that, what Hendrik said. So I think it's matter of how we can use these tools in conjunction, in a way that it provides more meaning. Like Kepler alone might not solve the entire problem. Cube Green alone might not solve the entire problem. Metrics logs alone might not solve the entire problem. So combining the different areas can create a, we can call like sustainable pipeline, that gives you the efficiency and reduces your footprint by using cube green, and different things. So I think that really makes sense, like piece of a puzzle, like putting each piece together to complete the puzzle, and creating a bigger impact. So yeah, like really enjoyed the demo you put up, Hendrik.
Again, I took the Slack action, but like I said, we could imagine to do a PR. I think that would be even more powerful, because at the end you have PR, and then with GitOps, you will automate the deployments of the sleep info. I had some issues doing that PR request, so I said, okay, let's do Slack, because otherwise I won't have nothing to show. So Divya, you had a question.
Yeah, I actually had a question regarding, the support of other resources. You mentioned that this is specifically for pods. Are there other resources that are, proposed to be, included in the roadmap for in the future for Cube Green, like stateful sets or deployment sets or something like that, or
So
um, in terms
what
of,
what
shutdown?
yeah, so great question. So Cube Green at the end is taking our deployments, so stateful set deployments, everything that has a number of replica, where you have the ability to touch the number of replica, then it will basically make those workloads sleep. You can also change the cron jobs. So if you have cron jobs running, it will also make those cron jobs sleep or not run at all. So at the end, anything that is in a namespace should basically should be impacted by the settings of kubegreen. So
Okay,
if you go to the documentation, like I said, there is at the moment a lot of various way of configuring it. And like I said, making some exclusion. So if you have an namespace where you have an API gateway that is used by other namespaces having traffic, then obviously you don't want to make this gateway being impacted by the kube green. So having ability to exclude, saying don't touch the API gateway, but the rest, yes, please suspend the work, is I think very efficient. But again, I think we could obviously think could be improved, like discussed. I think at least it's a good start. I think it's very exciting because as of now we didn't have any major options to do that, and now we can automate things. I mean, we can imagine automations using those tools for sure.
um
Amazing. Yeah.
thanks for that,
Very
thank
good.
you.
So there's a question. There was a question like interesting one, like can HPA auto scale to like you can use HPA for scaling down to zero. I think HPA doesn't support scaling down to zero. It only like it needs minimum one.
Yes.
Plus HPA only measures like it doesn't measure different type of utilization. So it's the not direct traffic that it will measure. So again, you have to rely on different set of metrics, and then you have to rely on different set of third party toolings like KDA to configure different deployments and then scale to zero. There's actually work within KDA as well. I think there's one project that points to the sustainability efforts. That's a different input type which is there. But Cube Green can work very well in conjunction, like we were saying, right? We are using different set of tools together to create something very much meaningful. So we saw something that Henrik showed today. That is a very interesting way to use. Another way can be using cluster autoscaler and Cube Green as well. So you can have those set of metrics, and then we can scale the HPA. We can have HPA, Cube Green, and Cluster Autoscaler, all three, and try to create some another scenarios. I read it somewhere. I'm not able to find it. I was actually searching very fast, but still not able to find it. So there are different scenarios where you can have the existing Kubernetes capabilities on top of this, a set of another tools which are a lot of rapid development, I would say, and then have something meaningful. But yeah, anything else, Henrik, you would like to add?
Yeah, I think if you take a solution like KEDA or HPA or anything, it needs a thresholds to that will determine if you add the number of replica, and usually this is relying mainly on metrics. And like I said, making query to get where you need to scale to zero, you need to have a very complicated query to say, did I have any traffic during a time frame? Because again, if you do that every seconds, then you will shut down pods, and then traffic will coming in, and that would be quite very dangerous. So I think you have to go over the past, looking at the last 2-3 days, and take action from there. Instead of because the way KEDA works is not going to look at the last 3 days. It usually sends a query. Again, you can define a more complicated query, but I think, yeah, I think KEDA is been designed to auto scale. I mean, in the name you have auto scaling. In HPA also, it's not there to define downscaling rules. You can scale and then it will downscale, but downscale to zero, it's not been designed so far for that. So I think KubeGreen, as of now, is the most suitable answer for that need.
Awesome. Great. I think we really learned good stuff about Cube Green and Kepler, both the projects, and interesting way how to use them together in conjunction with another set of metrics, webhooks, creating a complete workflow intelligently to auto generate the sleep info configuration that you saw for the Cube Green project. So thank you again, Henrik, for spending time, especially with the demo and the live demo, and it worked. So obviously it's a happy feeling, so everything worked.
All right.
So yeah, thank you so much for.
You're welcome.
Yeah, go
Thanks,
ahead.
thanks for inviting me here. And again, if you want more details, if you have any question about it, I will jump the example, the repo that the demo repo that I prepared. So then, if anyone wants to start uh, deploying those type of things in their environment using Dynatrace or other solutions, you can basically have a good base to start implementing that.
Amazing. So I'll take the repo from Henrik. I'll make sure I put that in the description on of this particular video, so that even when people are watching the recording later on, they have access, and you all have access to the repository, and you can kickstart your sustainability journey actually with the tools, and start creating an impact. And you can actually do it because everyone has dev stage environments at least. So definitely you will be able to start doing creating minimal impact at least. And that's what the whole agenda of this Cloud Native Sustainability Week is, to understand what, like, we always hear about carbon footprint, and we always hear about from the big companies, manufacturers, but there is something that we all can also use as the software professionals in the day-to-day world, and create a significant impact using the software technologies, because in the end it's running on the hardware. And if you see the Kepler project, they have mentioned there are various talks. I also plugged my shameless talk in there, where I have just mentioned all the details of how things are mapped. There is a proper research paper on that, how it is, how you can actually measure the carbon footprint from CPU, like from the CPU hardware, the different architectures. Nvidia, uh, Intel, like Nvidia for the GPUs, like Intel, they all are also working on the hardware level on the stuff that they are producing to provide metrics natively from their hardware specs itself. So I think work is being done at every level, from the manufacturers to all the global leaders. That is a separate discussion altogether. Plus the sustainability, like the tag is there, so everybody is coming in, putting in some efforts. And then the end users, because in the end we all have to use it to justify what is being developed. And I think this is the whole aim of the Sustainability Week, to gain the knowledge, to get stuff to get into our heads. Like, it's not only the political aspects. Whenever we hear about the term sustainability, it's actually much more than that, and we don't even have to care. I mean, it depends on totally on you, but if you are only caring about software and work that you are doing, you still can create a lot of impact by the current tooling which is out there. um, that's pretty much it that I have. And thank you all for joining in for the Sustainability Week. This was day one of Cloud Native Sustainability Week with Henrik, and we'll be back with day two tomorrow, same time, 8:30 a.m. PST. Any final closing thoughts, Divya or Henrik? Please, stage is all yours.
Yeah, I would encourage everyone to use those tools, and if everyone is taking those energy as a main KPI in their CI/CD processes, we could basically provide greener code to our users and reduce the energy for sure. So I think, yeah, if everyone makes this take Kepler at least as a good starting point, we can have an impact to our community, but to all the new applications coming out.
I didn't think of anything extra. These folks have pretty much covered it all. But a great way to get involved, as we mentioned at the very start of this session, would be to also get involved in the tag, because they are spearheading efforts, and they are also working in the open source space. We're all working in the open source space in some way or the other, so these are ways that you can actually get involved, and it's the best opportunity that you have to learn, and to also implement your learning somewhere. So yeah, that's pretty much it from me, and hope to see you all on tomorrow's live stream.
Awesome. Thank you all and see you tomorrow. Bye.
See you. Bye.